So if we look at, let's start with number B. Number B, I think it was straightforward, and then we were solving an exponential equation, but my questions now, what we're about to do and then what we did yesterday. Now, these questions here, they have the same variable of an index. So if you can check here, they have an x here. And then here they also have what? An x. But it's not so straightforward for us to say which we have an x and an x. Now, when we solve such questions, the first thing that we usually try to do is to change something into a prime product if it's not a prime product, provided it has an index. If it has an index, we have to change it. So here, because 2 is already a prime base, we're not going to change it. And then here we also have 2, it is a prime base, we're not going to change it. But 5 is also a prime number, we're not going to change it. But the first thing that we have to do then, it means that we have to split. So if we come and split this is going to be written as 2 to the power of x. All right, so if we are not going to change it to a prime product, we are going to split it. If we can't change it into a prime product, it's already in a prime product, then it means we split. We split. Now, after splitting, then we are going to check our variables. Our variables where can either be the same or they can be different. That's what we need to check for. It's either we're going to have the same variable, mahlang uhamba nge-transport. Now, we'll come and check our variables here. If you check the following variable, we have x in. And then there we also have what? Also have x. Now it means our variable index are the same. Our variables were to our index, they're exactly the same. Now, if they are the same, then how do we approach the question? We can then say, let's go and use something called the K method. So we'll come and say, let 2 to the power of x to be equivalent to what? 2. And then everywhere we see 2 to the power of x, we'll put what? If there's 2 to the power of x, here there's 2 to the power of x. Then it means that we'll have k multiplied by, so we have 2 to the power of 1 plus, we have k 2 to the power plus 1, and then this is going to be equal to what? 2. Okay. Now, after that, the next thing that we're going to check is that in our 2 terms, here's what can happen also, guys. We should be careful of this. Let's come and check here. Suppose we had 3 terms. Let's suppose this 5 was written this side. So they said we have minus 5, which is going to be equal to what? To 0. Now, we have 3 terms, Amish. Let's check, is there anything common between term number 1, term number 2, and term number 3? Is there something that we see with term number 1, term number 2, and term number 3? There's nothing like that. Now, we have 2 terms that have k. We have 1 term which doesn't have a k. Now, if the variables, as I said here, if the variables are the same, if the variable name and the variable name are the same, we are allowed to take the one that doesn't have the exponent to the other side. So we are allowed to take 5 lot to the other side. Because if we check 3 of them, they don't have something common. But if we just leave the 2 of them exactly the way it was, so if you simply concentrate and say here we have 2 terms. Now this is term number 1, this is term number 2. Is there anything common between term number 1 and term number 2? Now what seems to be common between term number 1 and term number 2? What appears in term number 1 and then it also appears in term number 2. So we are saying it's k. So we put k here, we say we have k, open bracket. Now if we take k here, what are we going to remain with here? So we have 2 to the power of 1 plus, we take k here. What are we going to remain with? 2 to the power minus 1. Close bracket, which is going to be equal to 2. Now you go to your Casio calculator. And we support Casio. And then we go and say we have 2 power 1 plus 2 to the power minus 1 equals to, it gives us what, 5 over 2. Ne? So we'll say, okay, we have, so we have k multiplied by 5 all over 2, close bracket. This is going to be equal to 5. Now we want to have k on its own. How would you get k? Okay, let's divide by 5 all over 2. And then this side will also divide by. And then, now, yesterday I showed, I think there were some letters that I showed. Guys, you already have 5 all over 2. You see that? 5 all over 2 is your answer. Now, if you go to your calculator to avoid, I get it now, you have 5 here. So you can come and say, okay, let's put it in a fraction. If you put it in a fraction, then you can come and put 5 here. And then here you say, I'm going to divide this by the answer. Remember, what is our answer? Answer is 5 all over 2. So I'll simply say 5, and then I'll divide it by the answer. If I say that, it says my answer is going to be what to do? So it says k is going to be equal to what to 2. But we know what is k. Okay, what is k? So we can come and erase here and say instead of k, but we have 2 to the power of x. Now from here we can then use the fact that if this base is equivalent to this base, now for the left-hand side to be equivalent to the right-hand side, this x should be equivalent to whatever is here. What is here? They didn't write anything. So if they didn't write anything, the index is 1. Then it means our x is going to be equivalent to 1. Now, how would we mark such a question then? We'll give you 1 mark for splitting. It's supposed to be equal 5. So we'll give you 1 mark for splitting. We'll give you 1 mark for factorizing. We'll give you a mark for simplification and then the answer. At most, it can be 4 marks. You don't have your books. Okay, you take them. This is how we mark this one. So it's going to be 4 marks. Now let's move on to the next question then. I want to relate these 2 questions basically. Now, if we look at this one, we have 10 to the power of x. And then we have 10 to the power of x plus 2. We have 106. Now, here, first thing that we do, we say if something has an index, we're going to change it into a prime product. It's true. It's true. If you have something which has a variable, if you have something which has an index of a variable, we're going to change it into a prime product. But I want to say something here, guys, especially if you are dealing with equations. There's something that it's worth noting. Now, doing that and not doing that, it seems as if changing 10 and not changing 10. Not changing 10, it seems to be much simpler than changing 10. Then the question that I asked myself after seeing this question was then, when do I know that I need to change? When do I know that I don't have to change? Then I thought about it. I said, let's go and check something here. Let's change 10 as a prime product. Now, if we say 10 prime product, we say 10 equals to shift factor. Now, it gives me 2 things. Can you see that? It gives me 2 things. Then I came up with this conclusion to say, if it gives me 2 things and then I'm dealing with equations, best I not change it. And I'm not saying which are wrong if you change it, guys. Now, every time when you're working with exponents, we change into a prime product. But I'm saying there are instances whereby it's not wise for you to change it. it's going to make your life a little bit complicated than if you left it like that. Where is that instance? If you are dealing with an equation, number one, if you seven on the equation and then when you change the equation, it seems to give you two things. It doesn't give you one thing. For example, if I had, let's say I had 4 to the power of x, then the question is 4 a prime number? 4 is not a prime number. Now, I'm going to change to 4. Let's go and change 4. If I change 4, it's going to give me 2 to the power of 2. Now, 4, it gives me one thing. Uti is going to be 2 to the power of 2. So, I am going to change this thing because 4, it gives me one thing. The reason why I'm not going with 10 is because 10 has 2 multiplied by 1 by 5. So, I'm thinking it's making my life a little bit more complicated than what it's supposed to be. So it's something that is worth noting to say, perhaps, if it gives us two things, let's not change it. If we're dealing with equation, I'm dealing with an equation. If I'm dealing with an equation and then it gives me two things, perhaps it's wise not to change it than to change it. Not to say that if you have changed it, you are wrong, guys. I repeat again. Now, if we use the principle that we are not going to change it, then it means we are simply going to say that we have 6 multiplied by 10 to the power of x plus 10 to the power of x multiplied by 10 to the power of 2 minus 1. It's 106, which is going to be equal to 0. Now, the next thing that we have to come and check, here. How many exponents work? Are they the same? Come and check the exponents. Do we have the same exponents? So, x, and then 1, x. So, it's not just something that doesn't have this variable, and then we're going to take it to that other side. 106 because our variables are the same. That's how we approach this question. So, with that being said, we'll then come and say, we're going to let 10 to the power of x to be equal to 2, k. And then it says we have 6 multiplied by k plus k multiplied by 10 squared, which is going to be equal to, start along 106 to that other side. It becomes what? 106. Okay. Now we have term number 1, we have term number 2. Is there anything common between term number 1 and term number 2? Yes. What seems to be common? Yes. Let's take out k. Open bracket. We have 6 plus 10 or 2. Yes. And then this is going to be what? 106. Now, if you say 10 all squared, I know you ask now. 100. Yes. What is 100 plus 6? So you have k, which is going to be equal to 106, which is going to be, I want k then. How do I get k? So divide by 106, and then it says k is going to be equal to 1. Now we know what is k. What is k? So we said, okay, instead of writing k, let's come and write it as 10 to the power of x. Now, after this step, we are supposed to change. We're supposed to make our bases to be the same. So, 10, 1. We're supposed to have base 10 and base 10. But we all can see which we have base 1 that side. Remember, we have base 10. How do we change base 1 and make it to be base 10? Now, we're going to use the principle that says that anything to the power of 0, any number to the power of 0 is 1. We can check that. So, in other words, we can come and write this as 10 to the power of 0. Now, let's check that if you don't believe me. So, we're writing 1 in another way. So, if you say you have 10 to the power of 0, what is 10 to the power of 0? So in other words, what we've done here, we simply said, okay, we had 1, we had 1 here. Now, instead of writing this thing as 1, we say to you, this is what we are saying. You can change U1 and then write it as 10 to the power of 0. Why? Because any number to the power of 0 is 1. Is 1. Now, from here, we have base 10, also have base 10. Now, our bases are equal. If the bases are equal, it means which x low, who's only with whatever is here as an index. What is our index there? So it says which x is going to be equal to what? 0. Now, as you can see here, I'm introducing you to the next topic for today, which is why we are here. There are instances whereby we are going to work with different indices. So here you have 2 to the power of x. Here you have x. And my index now, they are not the same. Can you see that? And then here you can come and check. Here you have x, and then here you have minus x. For x or minus x, they are not the same. So with that being said, I think